We are? Perfect. Good evening, everyone, and welcome back. So it's 5 o'clock here in London. Some of you have woken up in the US and Americas. So welcome to all of you who have made it to the talk. It's always great to have you live because you then get a chance to ask the questions to the experts we have on the talks. And we have three really incredible speakers today. I have already shared some information about them in Discord channel. So we already have Alison on this call. Alison, good evening. How are you?
I'm fine.
So good to have you. So good to have you with us. This is not the first time you're with us. We're really grateful. Last time I remember in August during the AI Accelerator, you came and you gave a talk to all of our participants, and they all really loved it. So this year I wanted to bring back all of these incredible speakers, particularly in ethics and data science. And so it's such a pleasure to have you back. We got fantastic feedback last year, and we thought we must have Alison again. And obviously, you are the founder of Women Leading in AI, and I hope you can tell us about it later on. But obviously, we do want to inspire more girls into AI, and that is so necessary. We desperately need more women in AI and data science. So it's fantastic to have someone like you on this call. So we are going to have a Q&A straight after your talk. And I know we have your talk, a recorded talk that we will be playing. So Sarah, whenever you are ready, we could begin the live stream with Alison's talk, and then we'll have a lively conversation afterwards. So
great. Let's get playing.
Let's do that.
My name is Alison Garner. I'm a lecturer at Keele University, and I'm also co-founder of Women Leading in AI. And today I want to talk to you specifically about the contact tracer apps that are being developed in response to the COVID-19 pandemic. The title of the talk here is Crisis Technology and How to Develop Ethical Technology in Response to a Crisis. Because when you respond very quickly and under an awful lot of pressure, it is possible to produce technology that can actually be quite harmful in the long run and can really infringe upon your civil liberties and your privacy rights. And so there's a lot of concern with some of these contact tracer apps that they become surveillance tools, that the data that is being collected would be centrally stored, and it could be used for other purposes, not just for checking on COVID-19 status and trying to retain and manage the pandemic. So how we balance this between trying to manage the pandemic, which we all want to do, and our privacy has been a big debate within the community. So just to explain a little bit more about these contact tracer apps, so the basic idea is that you can download an app onto your smartphone by various mechanisms, and there's loads of different protocols out there. Basically, your phone then will map your contacts that you do as you go around about your life and the status of those contacts. And if you have come in contact with someone who has tested positive, you will then be informed by your app on your smartphone that you are now at risk, and it will give you various advice depending on what that app is. So some might actually just say stay at home. Some might say, right, you need to go to be tested. Some might actually automate booking of your testing, and that's actually an important functionality, because I will say that only having a tech first approach or a tech only approach to managing the pandemic using these tracer apps without the wider support framework of manual contact and tracing and testing, these apps have minimal effectiveness, and that is worth bearing in mind as we go through the talk. So in the real world, in any disease that happens, that is an infectious disease, if somebody is tested positive, they will normally go to a centre and then they will be interviewed by a specialist nurse or officer who would then say, right, tell me who you've been in contact with. So if it's for a sexually transmitted disease, for example, it would be sort of tell me everybody that you have slept with and who might be at risk. And then there would be a contact process while those people would be contacted to say you have been exposed to this risk and we suggest that you go for a test. They don't actually tell who has been tested positive. So there's a whole set of processes around that, and normally it works quite well at a low level disease basis. But when you have a big disease such as COVID-19 that is infecting a large number of people and very rapidly over a short period of time, that process can actually become very, very overwhelmed. So what a technological solution would be to help augment that process. And this is what's really important to say. It should be augmenting a wide-scale real-world contact and tracing program. It shouldn't be replacing it, and it will only work effectively if it is it's included in a process where you have access to tests very easily, so that people are dealing with real facts such as I am testing positive rather than, oh, I've got a bit of a cold today and I don't know. You have to have that testing protocol in place. So these tracer apps could, if used correctly, help augment this process and be very, very beneficial. So the way that they generally work, and there's various protocols out there, but if you have your smartphone on your app, it is collecting your location data, and there's a number of ways it can do that, but it's just collecting your location data, and you go about your day's work, and it's recording all who you've been in contact with, sometimes where you've been in contact with, how long you've been in contact with them, and even how close you have been in contact with them. So all of this information can be recorded either on your phone or at a central location. We'll talk about that in a few moments. And then at some point on day 2, as it says here, for example, you realise that you're feeling ill and you actually get a test if you can get hold of one, and you test positive. Once you have test positive, you will then upload that information to your smartphone, and there's various ways that can be done, and to try and prevent gaming of that process or people refusing to do it or pretending to do it. And there's whole loads of abuse that can happen with these apps, so you have to be aware of that when you're developing. So for example, the doctor who has tested you, when you've got the positive test results, they would give you a code, so you can put that code into your smartphone and upload that information to the database. And then what will happen is immediately anybody you have been in contact with, usually was about the last 14 days. A lot of them are minimising this to about the last 14 days because that, for this particular disease, that tends to be the incubation period, roughly. Everybody will be informed immediately by their smartphone that they have been in contact with somebody and will be given advice. So if they've become in close contact, they might be told to self-isolate, they might be told to go for a test. In fact, the test might be even booked for them, as I said. And others who have had minimal contact, they're just sort of slightly warned, they're given an amber warning, if you like, that they're okay. And a lot of this traffic light colouring is being brought into these apps to give people their COVID-19 state. Worried about HIV, and it used to be, I've done it myself on job applications and insurance applications. They did once ask, have you ever been tested for HIV? And it wasn't that you were positive or negative was actually irrelevant. For you to have been tested for HIV, they would have assumed that you were in a high risk group, and that would have an impact therefore on maybe your loan insurance premiums, your loan rates, whether you got a loan, whether you got a job, so on and so forth. And that was soon swiftly dealt with, and you can't do that anymore. But the same concerns now are being raised about your COVID-19 status. So hence this red, amber and green. Going along with the metaphor for traffic lights then, so a lot of positives with contact tracing technology. They log exposures rather than relying on memory. They help speed up the contact phase, can automate booking, testing, and provide information on quarantine and healthcare. But some of the problems with these is that people tend not to download the apps. and there's been some research that showed that if you have 40% usage, this is about breaking out of lockdown. So this is one of the key things about these apps is how we do the exit strategy and we move out of lockdown. And this is the idea is that these apps will help us with that. And so Oxford University Group, the Big Data Institute, did some graphic modelling on what would happen at various percentage adoption rates of these apps, and if they use properly and effectively, how it can help prevent us getting that worrying second peak that people worry about. So the modelling that they did is that if nobody downloads, it's at 0%. At 20% download, we will still have a very high peak, in fact much higher than the peak that we're at now. At 40% it drops to about that peak there that you see in red, and 60% and 80%. And actual fact, what they say is that you need about 70% of people to download the app for it to be effective. However, there are problems with this. Go back again. Not everybody in the UK has a smartphone. Okay, so if you manage to get 80% uptake rate among smartphone users, that's fantastic, but that would only still cover about half of the UK population. 60% of people 65 plus don't own a smartphone. You drop down to 55, and I think that's about 45% of people do not own a smartphone. So you can see that it's actually not that common for people in probably the more high-risk groups to actually be smartphone users. So that raises those questions. And of course, we were also talking about children as well. And that's assuming an 80% pickup. As I said, the Oxford group think you should get about 70%. But in reality, even people who download the app tend not to use it. And in Singapore, which was one of the first tracer apps, and it was an ethical developed one called Trace Together, only 17% of the population installed the contact tracing app, which was launched last month. And so you can see that these apps do not have that wide amount of efficacy on their own. And so if a government, for example, produces this as its solution to exiting lockdown without that supporting network of manual contact tracing and actual tests, it actually won't have the effect that we hope it will do, and then we'll see some of those more worrying second peaks happening. There's also problems with contact tracing technology that people are worried about. They're very concerned about data protection and privacy and how that might be compromised. They're concerned about accuracy with false positives and false negatives. And now false positive means that it's said that you've come in contact with somebody when you actually haven't. So some of these technologies can pick up the signal and say you've been in contact with somebody who's been tested positive, but it could be your neighbour on the other side of the wall who you actually have never seen and you're completely safe from, but you've now been tested. So there's issues with that. And of course there are also false negatives as well, caused by a number of reasons, again with people in sort of uploading, depending on the technology, saying, oh, I think I might have it, I'm going to say I've got it, and they actually haven't. It's not effective, as I've explained before, as a tech first solution. It has to be embedded within a real world situation, and there are concerns of human rights and equality issues. So for example, one of the things that people are worried about is they really want to break the exit strategy. They want freedom. They want to be able to go out. In very many ways, they're willing to give up their privacy of their in-person information, their personal health data, so that they can be free. And it's about trying to balance people's right to privacy and their freedom. And that in a stressful situation, they are not being forced to give up their privacy because they're panicking about wanting freedom. And if you develop what's called a privacy first app that has real data protection in there, you can actually manage to get both if you develop them properly. Also, you have to have issues such as consent. Now, you have what's called informed consent. So when people understand exactly what it is that they are doing and why they're doing it, and what information they are giving up, and that is informed consent. Meaningful consent is to set up an app, a technological solution in a way, and the policy and the guidelines around it, where that actually people aren't just seeing a huge list of criteria and you've got to click agree, and people just, oh yeah, I don't care, I just want to be able to go to the shops when I want, yeah, I agree. Meaningful means that, yes, I agree with that, but I am going to actively share my data when and how I want, and they fully get involved in that process. And it's not this, well, do you want to die quickly or do you want to die slowly, false choice that you get, when actually the third choice is, well, I'd rather not die at all, for example. So in the development of these apps, there's been two ways of doing this location data. So you have various things such as GPS. Well, that will record your exact location, and GPS is only accurate really to about 15 meters anyway. It will track your actual location, and from that it will it is possible to identify who you are, where you've gone, and if that information is stored locally, centrally, and can be used for other purposes. This is where we start getting real concerns about surveillance and what will happen after the COVID-19 pandemic dies down. Is that going to be a mechanism by which we start having a population which has been highly intensively watched? So another technology is Bluetooth, which is accurate to 2 meters. There is, again, the little traffic light there is explaining to you that it's always not perfect anyway. How you are in 2 meters could be on the other side of a door or in a crowded room. There is issues with that accuracy. It links device to device, and that's quite important. So rather than actually doing your location data, it just tells you you've been in contact with another smartphone app user, and it just speaks device to device. So you can actually make this a lot more anonymous, depending if you set up your what information is collected, and it improves your privacy therefore with that process, again depending on what information you have been required to link with that smartphone in the first place. So the Bluetooth is an issue there. There's also issues where some of the tracer apps require you to keep your Bluetooth on the whole time, and that then not only does it drain your battery, but it exposes your phone to being hacked. So if you've got your banking on your phone and all of this information and you have your Bluetooth permanently on, it really does have some security issues and privacy issues are all resolved around that. There is something called Bluetooth low energy, and a lot of the apps now are opting for Bluetooth and opting for Bluetooth low energy, which is much less energy intensive, and there are some processes where you don't have to have your Bluetooth on the whole time anyway. So I keep mentioning centralized and decentralized data. So this is the idea that you get this information on your phone, and all that data goes to a central storage unit, and they manage and hold that data. Decentralized data is the fact that this data is only ever held on your actual device. On your device, you own it, you control it, you can decide when to share it or not. And this is what I talk about by meaningful consent. And this is where there's been a big fallout at the moment between various frameworks and groups with regards to how this should be done. And so on one side we have centralised. Now the NHSX and PT frameworks that are being developed, they are partially centralised, partially decentralised. Other apps such as Safe Paths by MIT, the Singaporean Trace Together app, both of those are open source by the way, and other frameworks such as DP3T and Google and Apple work on a decentralised approach, which is actually much more privacy first approach. So this would be the recommended approach. So this idea of decentralized data, you hold your data on your phone, you are in control of it, not some central agency that you're going to have to trust, and you do not know what's going to happen to that and what they're going to pass it on to, without real legal protections, which we still currently don't have here. So how can you ensure data privacy and anonymisation? Well, if you use the Bluetooth system, what some mechanisms do is that your phone will produce what's called ephemeral IDs every 15 minutes or so, and you'll just ping them all the time, and it's just pinging out to other phone devices. So as you come near them, it will record that ephemeral ID and locate and store it on its mobile phone. And then what will happen if you then test positive, you will put in your positive infection rating in there. It will note all your ephemeral IDs. It will be sent that off. So you select now to send that information off. So it does go to a central location, but it should only be those IDs. There should be no personal information there at all, and that will then be allowed to trigger out anybody else who's come into contact with that ephemeral ID. They know they've been in contact. So this really helps with anonymisation. Other anonymisation mechanisms actually are what's called can be worked around. They aren't really removing your name and your address and your postcode doesn't necessarily mean that your data has been fully anonymised, because you can aggregate data and still work out from that process who you are and where you've been. So key things about any data privacy first approach is that you only collect the information you genuinely need to know. People will create a case for knowing more, to prevent abuse of that data, so you know it's not going to go anywhere or be used for any other purpose. There is no need to track non-infected users, so anything that retains that information should, you have to question. And also, as the pandemic is over, that this technology should then be completely dismantled and removed. There is no need for it to continue afterwards. Interestingly, Google and Apple are forming an operating system framework, because all of these apps have to work together, and they have to work in a way that speaks to different operating systems. So if I have an Android and you have an Apple, those apps still need to speak together with each other. So Google and Apple are working together, unusually, on developing this operating system API, and so that all of these tracer apps can actually integrate with them and talk to each other. And quite interestingly, they have fallen out with NHSX Digital and a number of other governmental tracer apps, because the governments are wanting to have this centralised data, and that goes against Google's and Apple's privacy standards. And so there's a bit of an impasse there. And so what Google and Apple are now looking to do is that actually what they'll store download automatically onto your operating systems is actually a tracer app within itself, but they have built in this dismantling process that it will end afterwards. We have to decide whether we trust them in that or not. There are systems such as MIT SafePaths, which use information that Google already have, so you're not adding any new information in there. So what we really need in looking at these tracer apps is they are not bad. We do think that they can add some real value to the whole process and speed it up, but they only work in context of a full system of contact tracing and testing. We must ask for what's called sunset clauses in them, so that once this pandemic is over, this technology then becomes obsolete and it gets rid of and it stops working, so that we do not end up finding ourselves in a society where we are being constantly tracked and surveilled by our governments. So therefore the use of the data should only be limited to COVID-19 purposes, and only very, very narrowly, no excuses, no trying to stretch that purpose and have scope creep, only to COVID-19 processes, and any sharing of data with third parties would have to be defined by law. And there's a whole load of other facts there that I've put down, but these are the key ones. So I'm not talking against these apps, but I think we need to be very wary that it's how we deploy them, and that they are a privacy first solution, and that they protect our civil liberties. Thank you.
Wait, now.
Okay, do we have the sound? Can you hear us now?
Yeah, the sound is back now.
Perfect. All right, fantastic. So we're back live. And thank you very much to all of you who have tuned in. We are looking for questions. If you have any questions, now is a good time to ask Alison. So apart from the incredible work Alison is doing with women leading in AI and addressing all the privacy issues, she is also leading a data science apprenticeship program at Keele University. So if you have any questions as to how you can get into data science through a slightly different route, maybe not directly through a university program, but through an apprenticeship program at university, a degree apprenticeship, which means you are in the industry, and at the same time you will end up becoming a data scientist. Alison is the right person to ask those questions as well. So we have a question from Lydia, and she wants to know, can you please explain ephemeral ID a little bit more?
Okay, so what these are, well, again, there are, if I recommend you go onto the Wikipedia page, because they've got a whole table listing them all, so they all use different mechanisms. So an ephemeral ID is, rather than your phone can generate, or the app can generate these constant codes, which are your IDs, and some tracer apps will link those with sort of MAC addresses, and you can link them back to your actual phone number, but others can be completely randomly developed. And the better one, the DP3T framework, what it will do is every 15 minutes it will generate a new ID, just completely random, and that will be what's pinging out via Bluetooth to any surrounding device that can pick it up, and then that can be logged, and then it changes. And so again, it'll change to a new one and a new one and a new one. So these IDs, and these are all logged locally on yours and locally on so that you can find it. So they are not linked to any personal data whatsoever, and they do not last. So they don't become a permanent ID that you can be used and is centrally located. So it's a way of ensuring your data is anonymized and completely and retained upon your device. But there's various protocols for developing those. And I will add, because I think we were muted, I know I spelt Bluetooth wrong. Apologies.
Fantastic. Do we have any other questions? I'm not any come up, so maybe then it is time for me to ask you a question. So, Alison, I am really concerned about what's happening right now in the context of COVID. The intention for this hackathon is to get a lot of young people together and try and tackle some of the pressing issues that we are experiencing with COVID. So in light of this, what tips do you have to offer to them? What should they be mindful when they are exploring technologies such as AI and data science? Some of these technologies are quite advanced. As you may have noticed, some of the young people are trying to integrate facial recognition into some of their apps. You have seen the tweet from Andrea from one of the teams. I believe they're trying to trace focus, in a school online environment, remote learning, whether teachers could trace children's focus and whatnot. What advice would you offer them? Because we don't want to get it wrong. We are working with very young people here, and we want to make sure they understand the implications. If you could offer them any tips, I would be really grateful.
Well, I'm sure you probably already heard the words unintended consequences. So whenever you plan a tech solution, you really do have to forward think and sit down and go, what are the unintended consequences if this is not deployed in the correct way, if we get scope drift and so on and so forth. So really, really criticize your own plans. Think where it could be abused, think about how it could be inaccurate unintentionally, and work that through. And you cannot just think of the tech solution on its own as a cool solution, or we can utilize that technology and this technology, we could do this within your own mindset. You have to look out and how it will be deployed, used by others, and the wider ecosystem of which that app or that piece of technology will exist. So sort of one example, I think, well, using the tracer apps, They've been sort of very anti this idea of facial recognition involved in that, because of mapping that, and you can start locating and surveilling people. And if you have centrally located data within your centralized data solution, and it's held by an organization that also has your facial recognition and your mapping data, then you can aggregate that and start having the situation where you lose your privacy. And it might be that we're happy to do that now, but it can't be, long term. It could cause more damage, because we are trusting our situation now as it is in existence and history, but in 10 years time we could have different governments and different situations that we're in. I saw on the Twitter, and I would never sort of argue against it, but you can do technology right. So I've looked at facial recognition where it's been deployed, and people have been very nervous about it, but if you put the correct safeguards in place and you deploy it, and you develop it and deploy it ethically, it can actually be very useful. But it's thinking about that aspect. So looking at the example on Twitter, which is about using whether you're focused or not, you have to be careful that in your homogenous group or people in your own mindset, you're not thinking about how you work and how your personal experience, but you've got to think of a wider difference of opinion in different cultures. So some cultures, it's rude to make eye contact, for example. Other cultures, other people with other ways of learning will look away whilst they're concentrating rather than at the camera. So how can you map that? Because it's a very individual thing. So it's not that you shouldn't do it, but necessarily you've got to think about how you will do it correctly and make it. And sometimes it could be that you go, well, no, we can't do it this way. We can't make it that sort of granular, and therefore it's not a good tech solution. And you also have to be very brave then to not go ahead. But the thing is to make sure you have diversity within your team and your thinking, so that those type of questions get raised and you don't run to a solution. And then you have all the problems of algorithmic bias and so on and so forth, and inequality and discrimination that can come out from very well-meaning development, but it's not been thought through.
So we have another question. It's how can we ensure that data is deleted after COVID-19 crisis is over? Is it a legislative issue or more of a trust issue? And I just wanted to clarify what kind of data they were talking about. And an example that they gave was location data, if the GPS route is followed, as an example.
Yeah, brilliant question. And actually, there was the Select Committee for Science and Technology was on this morning, and it was made very interesting watching. And that has been the question that they're asking at parliamentary level. And this is where you get the disparity of going, oh, well, trust us, we will delete it afterwards. And the request by a lot of people, such as Professor Lillian Edwards, who drafted the COVID-19 technology bill, example one, so check that out, is that no, it needs to be put in hard law. And the systems need to be inbuilt for, so when at the end of it actually naturally finishes, and you have to build that in, because trust is a big issue. People don't trust it, and they have to have that issue, and you have to do that by hard law. I think there's been too many examples where trust has been broken for people to feel comfortable with it. But there is this fight back between people who are very interested in developing it, saying, no, we'll be all right, we'll do it, trust us. And you have to question that. So an example, and I read, and I haven't got the reference, so it would need to be verified, but in the development of the NHSX app, other organisations are involved in that, including GCHQ. Now, they could be on an advisory capacity, and that's fine, but you have conflicting interests there. So, and even if that's not true, you read that's the question. So I think, yes, we do need legislation, and Australia have just put one through. So it is doable. So I would like our government to do it in the UK if we can.
Oh, this is fantastic. I think we have another question. Sarah, do you want to read that as well?
Yeah, so we have, if data was to fall into the wrong hands, what would be the worst and the best that could happen? Oh.
Okay. Oh, I like the fact that they've done the best. I love that one.
Including both positive and negatives.
Yeah, right. So the best thing that will happen is, and this is, you will get the epidemiologist requesting this level of data that for example, the NHSX app wants to have, which is quite a lot of personal data involved. And they say that it's going to protect your privacy and it's going to be centralized because they want to be able to research. And that information will be really valuable. So give you a lot of research into how the disease spreads, and it will give you some idea of how to contain it in the future, because it's not going to go away. And this is trying to balance the cost and the risk with the benefits that you have, and weighing those decisions up, which is why in my presentation I did a lot of the bubbles, and where you can try and get in a middle road through if you can. So that's a challenge. That would be the best thing, is that we would get good scientific data and research from it, I think. The worst thing, it depends. Well, a lot of the worst things is that they could have discrimination, and vulnerable groups could be deeply discriminated against. If you have situations such as COVID-19's status, and you apply for loans and mortgages and jobs, and that information is out there, that could affect your livelihood and your ability to get jobs and get loans. And also, there is the bigger concern is about the loss of civil liberties and being highly surveilled as a population, and therefore controlled. And they know where you are, when you are, and they can enforce then for you to remain at home and track you that way, and have so you could try and go out. And I'm sure people are desperate to go out, and you shouldn't be out because you've been down as COVID-19 positive, and they track that you're out, and then you're swooped on by the police. And that's an extreme example, but that can happen. And it's suggested, that we have immunity certificates to allow us to go out and about, and passports to allow us to travel. And so real reduction in your civil liberties, and finding yourself literally locked in your home because you can't go out, as a long-term thing, could really be damaging, especially if that happens disproportionately to vulnerable groups.
Phoebe just made a little comment, and she said that you just reminded her that in February, before the lockdown started, she saw someone carrying a bag which said that GCHQ is always listening to our customers. So that's just a little comment that she made. We have another question, and maybe it says, what if our solution is to help with the COVID crisis, but we believe it's equally needed outside of the COVID crisis? What should be done with that data? E.g., like loneliness with the elderly, which is a problem that occurs within the COVID crisis and outside of the COVID crisis.
So what was the first part of the question? What were the data that they collect about loneliness?
Yeah, so she's asking a solution, like the solution that they're working towards for the problem is collecting current data during the COVID crisis, but the data that they're collecting could be very useful outside of the crisis. An example that she gave was loneliness within the elderly.
Right, okay. So that's picking up on a comment on the slide, which is where the data should only be used for COVID-19 purposes. But there is a follow-on from that, and this is why bills can be quite long sometimes. I think Lillian Edwards' one is about 8 pages long, is where if it needs to be shared with a third party, and outside of that use case, then that has to be passed in law or via government approval. And so there is a level of control in that as to where that goes, and of course what data then is passed on for that usage, because it's about the data minimization philosophy, that you don't necessarily need to pass everything on outside to that group that can be used for those purposes. So saying that it can only be used for COVID-19 purposes, and then when it ends, get rid of all the data and delete it, I think that fight won't be won. Which is why tracer apps that retain your data on your own device, and you only share it if you so choose, and only if you are testing positive, will help protect some of that as well. So this is about the design of those apps and what data is collected at the outset, because you're thinking as that team has thought about the long-term consequences. Well, what data we do collect we can use for other purposes, and they're thinking right ahead, and that's really positive, because that will impact on the decisions you make now and what you develop and how you develop it, with that in mind. So I'm not that hardcore that I would say no, you can't, but it's what data then you would choose to pass on.
Yeah.
All right, so that was fantastic, Alison. Thank you so much for responding all these questions. So everyone, I will invite Alison into Discord so that you could pick her brains, based on whatever it is that you're developing. So Ankita, well done for trying this live, picking Alison's brains. But Alison will be in Discord, hopefully at least for half an hour or an hour. So grab her when she's there. We do have Gretchen Green there as well, another ethicist. And if necessary, I could also invite some other ethicists into our Discord channel so that they can work with you, because it's very important that we do get this right, particularly if this technology is deployed and if you do decide to take this forward. So it's very, very important. So Alison, I am so grateful for your time, and we won't be keeping you, but I will send you the invite, and it would be fantastic if you could join us in Discord at least for half an hour or an hour, so that young people could ask you some more questions, because as you can tell, they're right in the middle of building. They've only just started building. They have already gone through the phase of design thinking. They have by now spoken to a lot of the target users that they are developing this product for. Some of them have managed to get more than 100 responses to their surveys. So we do encourage that. And they have been all over, Facebook and LinkedIn and Twitter, collecting that data, speaking to the people they want to engage with, whose problem they are solving. And right now, what they're doing, they're analyzing this data, and that data will inform the product that they will be building with the help of the mentors that they have in Discord. As I agree with you, we need to embed ethics in the entire product development cycle, and as early as possible, so that they really do consider those issues very early on. And so I'm very grateful you are with us and you're able to offer us all those comments. And Andrea, so Alison has already offered you some advice here, but she's coming to Discord, and I recommend you directly speak to her about facial recognition and the tracking that you want to introduce in your product, because I think it's very crucial that you apply it correctly and ethically. So Alison, thank you, and we'll see you in Discord. On this note, everyone, we do have another recording we wanted to show you, and this comes from Rob Armstrong from Tesco's Data Science Lab. So Rob cannot be with us live, unfortunately, and that is because he is on an urgent call. But we do have his recording for that specific reason, because we are dealing with people at the very highest level of their careers, and they can't always be available for us on the call. But we always make sure we have recording prior to this call. So Sarah, whenever you are ready, we could probably listen to what Rob has to say, because his talk is specifically about his journey into data science. And I hope you will also have some questions for him. He won't be able to take these questions live, but we will share these questions with Rob. And as you may be aware, there is a team of data scientists already in Discord. They are from Tesco's. Alistair, I am referring to you, and Francesca. So we have a number of them in Discord, and they're all assigned to different teams. So if Rob can't answer them today, they will be able to respond to you. They are very friendly. They're there to help. They're all data scientists, and they will be very happy to share their experiences. So Sarah, let me know when you're ready.
And we're going to play the video.
Fantastic. Enjoy.
Hi everyone, I'm Robert Armstrong and I'm the Director of Data Science at Tesco. I've been asked to talk to you today about my journey in data science, as well as the impact that it's having at Tesco. So over the next few minutes, I'm going to answer a few of the questions that have come in, and I hope you find it interesting. I've been with Tesco now for almost 4 years, and over that time, I've had a chance to build a team of more than 50 data scientists and machine learning engineers that are based all around the world. I can also look back over the years and quite neatly track my career progression against the core types of analytics, the 4 main types of analytics, that ultimately help to bridge the gap between having a source of data and ultimately making a decision and taking an action. I actually started out my career in the telco industry, and it was mainly working on descriptive and diagnostic analytics back then, which was focused on mainly developing reporting and analytics to help answer questions which were really looking backwards into the past and focused on the kind of what happened and why did it happen. That type of analytics helps to partly bridge that gap between data and action, but it still takes quite a large amount of human input and interpretation on top of it to help bridge that gap. During that time, I actually got a lot of opportunity to move around a lot of different teams, including customer insights, customer experience, pricing and propositions and strategy teams. And it was moving around these different teams within the businesses that really gave me an appreciation for how data can be used to drive decision making and the real value that it can bring to a company. Following on from that, I spent a number of years working in the high-tech sector for companies that were based out of Silicon Valley. And it was really, I made the step at that point from purely looking at the descriptive and the diagnostic, which looks backwards, to more of the predictive and prescriptive that is looking forwards. And instead of answering the what happened and why did it happen questions, it's more focused on the what will happen and what should you do type of questions to maximize your impact in the future. I was also fortunate that it was around this time that data science started to become a distinct entity within companies. And I was actually lucky to be a founding member of one of those teams that was being built out. So really got an opportunity to see right from the start, the early days of how data science has evolved within organizations. And it's really that predictive and prescriptive analytics that has helped to bridge the gap even further and take you from having a data source all the way through to a point of action, and minimizing the requirement for having a human in the loop to inform that decision making. And it's really, that's been the focus of the time, the 4 years at Tesco, has been building out the prescriptive analytics and data products that help to bridge that gap. I'm really fortunate that I've been a part of analytics and data science teams across a number of great companies, but they've all had a slightly different definition of what data science is and how it can add value to the different companies. When I joined Tesco, we had an opportunity to build a data science team, and we've evolved that over the years to really fit the changing needs of what data science and value it can bring at Tesco. At its core, our data science team develops algorithmic product features and platforms that support and automate and optimize decision making across the business. And I think the best definition we've been able to come up with for what a data scientist is that it's someone that can obtain and explore and model data by blending maths and algorithms and a scientific mindset to really drive that support and automation of the decision making. And our team really covers a lot of different technical backgrounds, including maths and machine learning, statistic, operational research, and the broader AI space. And it takes all sorts, so all of these kinds of backgrounds to really build a performing data science team. So as I mentioned earlier, we've built data science out as a centralized function within Tesco. And it's made up of data scientists and machine learning engineers that are focused on building out these algorithmic product features, part of technology products running across the business, as well as platforms that are ultimately there to support and automate and optimize decision making across the company. So over the last 4 years, we've really grown it from being a very small team based out of one location to being a 50-person team all around the world. We've added locations in our head office in Welwyn Garden City, as well as London, Krakow in Poland, as well as Bengaluru in India. And the way that we operate is as agile product teams, and we're a member of those agile product teams, developing essentially software products and software applications. And the teams are made up of lots of different job families from across the company in technology, including product managers, software engineers, data scientists, analysts, and business partners. And it takes a product team of all of these types to come together to build these successful data products. We really believe that it takes a combination of lots of different types of skills to make a successful data science team. And we've got examples of a variety of different backgrounds in the team, including the sciences, as well as maths and statistics and engineering and computer science and finance. But as a centralized team, working across all of these different parts of the business and technical domains, we're ultimately looking for a wide selection of backgrounds and skill sets, and it's not a case of one size fits all. We do look for data scientists who have a scientific mindset, and they want to work on challenging problems, and also that have a strong foundation in maths and statistics and computer science. But our data scientists typically have a very good understanding of machine learning and algorithms in general, as well as different specializations depending on the area that they might work in. So we have specialists in machine learning and operational research and computer vision, and we put a big focus and emphasis on applied experience. So the value you get from data scientists, we strongly believe, is in getting your developments into production at scale in the hands of users. And so having applied experience of how to work on those problems at scale is really important for us. So without a doubt, implementing data science powered products can have a transformative impact on a business. And we've definitely seen that within Tesco. Take, for example, our online grocery business, which is the largest in the UK. We're actively using decision support and decision automation applications to help our customers to get what they want, when they want it, wherever they want it. And our developments are helping to anticipate customer needs through personalized product recommendations and prioritizing what our colleagues can do to help facilitate that process. This allows us to tailor a seamless experience and a great experience for our customers. One of the key developments that we've worked on was optimizing the picking of billions of products for customers and getting those customers delivered to millions of homes every single year. These developments help us to keep costs down for customers. They increase the availability of delivery slots as well, and they reduce our environmental impact. Optimizing the last mile delivery has saved millions of miles of travel time for our vans, and it's reduced our corresponding CO2 emissions with that. Other areas we've worked on have helped to optimize price reductions within our stores to make sure that we're minimizing the amount of waste within them, as well as developing longer range forecasting, which can help the business to better anticipate what might happen in the future and plan accordingly. So I studied maths and sciences at school, but I also did a lot of music, and I especially enjoyed the more practical side of and technology side of recording and producing music. I actually took music technology at A-level, and you find me most of the time in the recording studio, either mixing or producing the tracks that we were recording. And I really enjoyed that aspect of the work. I really enjoyed building something and spending the time to craft it into a final product. At the time, the final product that we were making was a music track, and I guess you could draw the parallels to the world of data science and ultimately crafting a product that has an algorithmic aspect to it in the same way. around the question of why physics at university. Honestly, I didn't know what I wanted to study at university, but I thought that physics would open up the most opportunities afterwards. I didn't really know what I wanted to do after university either. Again, I really enjoyed the practical aspects of physics and lab work, and being able to spend time within a lab, again, building something, crafting something, and experimenting, which is again similar to the world that I work in now. It was at the end of my my bachelor's, that I decided to then go on and do a master's in operational research and management science at Warwick University. And that really provided the bridge and the foundation for all of the work that I've done since then. The combination of the mathematical and statistical side of physics with the business optional modules that I'd taken during my bachelor's, really, I enjoyed that combination, and that's what led on to my first jobs within industry. So I think programming is at the heart of everything a data scientist does. And so my first piece of advice would really be to focus on developing your coding capability and become the best programmer that you possibly can be. I really believe that programming is going to become a second language, or need to become a second language, for so many people in the future as the world becomes ever more digitized. And we've definitely seen over the last few years that the skill set of our data scientist is moving ever closer to that of a software engineer. And the need to write high quality, scalable code is helping with deploying our applications and driving real value from what we do. I think the second piece of advice I would give is focus on gaining applied experience. Every problem that you can work on and that you overcome, and those challenges that are a part of it, will help enrichen your toolkit for data science. So focus on working on as many problems as you can, and ultimately that will help in the future.
Okay, shall I?
Yeah. So we're back live.
We're back live. So fantastic to have had Tesco's talk, and I can see you have posted some questions. What we will do is we will take those questions and we will share those questions with the Tesco's team, and they will be able to respond to us, and hopefully either in Discord or by email, and then I will share the responses. And in the meantime, so do keep those questions coming. If there is anything you would like to ask about the data science journey, or what Rob has done in the past, or whether Rob Armstrong is in any way connected to the Neil Armstrong or whatnot, so please do ask those questions in YouTube or in Discord, and we will share them with Rob. And I think he will be very happy to receive some questions from you. And in the meantime, we do have Raj on this call. So Raj, how are you?
I'm fine, Elena. How are you? Thanks for inviting me.
Yes, no, it's great to have you. And I am going to ask Sarah whether we don't have any issues, I hope, with any screen sharing, and we're good to go. So we're going to have this talk live. So everyone, Raj will be sharing his screen. So please do let us know in feedback on YouTube whether you can comprehend and whether you can see the slides. And if at any point we have any issues, please let us know. If something happens like what happened yesterday, we will send you back to Discord and you can continue the conversation there. But let's hope nothing happens. So Raj, whenever you're ready.
Just a little quick note beforehand. We will be recording this call, this talk. Hopefully that's okay with you, Raj. And we will be posting it. We will be posting it to YouTube after the the call
Yeah.
is done.
The live
Yeah,
stream.
that's perfectly fine. No problem.
Fantastic. And also, Raj, if you could share your slides in Discord, we would be really grateful because I know you have a lot of slides to share. And just to warn you, you're only live on air for 30 minutes. We are going to hope we're going to try and take questions for 10 minutes afterwards. We're going to see the engagement on YouTube. But I know you are already in Discord. And if they have any questions, they could also ask you in Discord. So everyone, this is a 30-minute talk, and it's going to be about COVID context as well, but real focus on AI and machine learning. So particularly those of you who are technically minded will find it really interesting, but please do stay. You will all find this talk very insightful. So thank you, Raj, and whenever you're ready, do begin.
Yeah, thank you. Thank you, Alina, for putting this event together. That's a fantastic event in the crucial time. So, I'm a CEO at CyberPulse and co-founder and CTO, Chief Data Scientist, Vastmind, which is the startup we co-founded 12 months before, and we more focus on data-driven healthcare. And I also a course leader at University of Oxford for AI. So this talk is all about my experience going through this startup and what the research I did by following the research from Oxford University, Imperial College of London, King's College of London, Harvard Medical School. So I just kind of put together everything in this slide. And the idea, the first part of the slide is I'm talking about here. This is I would like to explain in here. So first thing is about all the features which we extracted. What are the research behind those features when we extracted those features, and what research being done. The next section I'll talk about AI, what basically not too much in depth about AI, but kind of high level AI, and what we are using in. And the third section I'm talking about the app which we are building, the screening and diagnose app for the COVID-19, and what sort of algorithm we are using and what's the technique we are using, and a bit of question on that. So that's kind of sum up this session. So, so if I go a little bit down, so this is a bit of history. I did some research on that, this viral infection roadmap, because this pandemic, COVID-19, but we are not here first time. If you look at this slide, we have SARS in 2002. I kind of put together a little scribble about how this spreads and what are the hosts and how it is mutated and what's the case fatality rate. Just a bit of scientific evidence behind all these events what happened in past. So SARS came in 2002, and the host was bat, and then it was transferred to civet, then to the humans, and then come MERS. MERS was in 2012. And the epicenter of MERS was Middle East. And so the host was bat, then to the camel, and then to the humans. And then now in 2019 in Wuhan, China, it was again the host was bat, then mutated to the pangolin. So why it is so spreading? There is a theory behind it, because pangolin is got a very the healing power. So for that, the spreadability, it makes it spreadability like more spread more fast in that. Then comes to the human. This is the theory. Still, there is a lot of research going on in that area. So if you see the case fatality rate in all these three events when the virus spreads, so case fatality rate is number of deaths divided by total number of cases. In case of SARS, it was much bigger. Then in MERS, it was more than that. It was 34% case fatality rate. But in COVID-19, if we see how many total number of cases we have and total number of casualties, it's very less. It's 3.7%. But it spreads very fast because of mutation through pangolin. That's the theory behind it. Then little bit more detail about SARS, what it was. So again, as I said, it was in 2002, and that was called as SARS coronavirus, and it was in the Hong Kong, and it spreads like that initially. The physician who traveled different places, and that's how it was spread. And then it was the epicenter was outside China, and it was a kind of a very serious issue at the time. Then I would like to talk about MERS as well. So this is the Middle East Respiratory Syndrome coronavirus. So it was, again, as it suggests, the epicenter was Middle East, Saudi Arabia, and that was another variation of coronavirus, we can say. And again, if we see, like, the primary host was bats again, then go to then camel, then humans. Then 2019, yeah, in Wuhan, China, there was a cluster of pneumonia cases found out, and then there was a research being done on that. So we then the coronavirus is called as coronavirus disease 2019. That's what it was identified as COVID-19. It has two names. But in database, all the genome sequences, all the sequences which we are gathering those. And one thing to note as well, because the virus can have two structures, DNA structure and RNA structure. And the COVID-19 has RNA structure, and that spreads very fast. So that is, uh, uh, again, we see the spreadability of it now, because that's why we have these lockdown and all these things. And I'll tell you a little bit about those things. So if I'm talking about the virus and all this research, there is I think it's useful to know about what are the transmission levels, for example, in that. So we have, like, we can say 4 transmission levels. One is the level 1 exposure, level 2 infection, level 3 transmission, level 4 epidemic spread. And when see pathogen is the organism causing the infection. For example, when it goes to the humans, it becomes a human pathogen. So if I'm throwing those terms, but it's good to understand if you're going to the AI in healthcare, and if you're looking for progressing or career into healthcare, the digital driven healthcare, it's useful to know those terms. And these are the levels. So I think we are somewhere around level 3 and level 4 at the moment for COVID-19. So these are few symptoms for COVID-19. We'll say high fever, tiredness, and dry cough. And that's what we are extracting our features for when we are building the algorithm, so that when we are testing out in the market, we kind of validate on these basis, these parameters, these features. There's another scribble I did I was just researching a little bit on that. So this is a kind of the critical part of this COVID-19 is the lung, is basically the respiratory is a fact. That's where there's a lot of demand for the ventilator. And I was trying to understand why it does that. So there is a WOB here, if you see in the picture, it's called work of breath, we call it. So work of breath means, like, the system has to do more work to get the oxygen. That's what this does. And PO2 is another parameter in there, which reflects the amount of oxygen dissolved in blood, and it measures effectiveness of lungs to pull oxygen to the blood. It actually affects those things. And another parameter in respiratory rate, how it is impacted or not, whether the value of our respiratory rate is according to standard or not. And this is another factor, the very good factor which we are taking care in an algorithm is HRR, heart rate variability. Heart rate variability is basically degree of acceleration of your heart rate. So that is really connected to the ANS, which is the automated nervous system. And automated nervous system connected to the hypothalamus, which controls the whole body, like flight or fight mode. So this is one parameter we are using in our app also to calculate what is the value of HRR, so that the combination of respiratory rate, the PO2, and work of breath, and HRR, so we can determine whether the person has some sort of COVID-19 symptoms or not. And there are some people, those who doesn't show any symptoms when and there is no way to know without testing whether they have COVID-19 or not. And that is the problem. That's why all like with the Singapore or South Korea, they're more focused on 333 framework, this test, track, and trace. And a lot of apps around it which are doing that. And this is the fact also, 80% of the people recover without any special treatment. That happens. So I was doing one research on that. There is a thing called virus load. So virus load is the density of the coronavirus droplets going to the airborne on the respiratory system, and that's volume. Does it matter or not? That's why, like, those 20% people, if they are exposed to the heavy virus load, the chances are, because they are affecting the immune system in a like more like bigger way, and that's why they are more critical than others, those who are. But there's still a lot of research going on. I'm not I didn't find any conclusive research in that area. But still, like, there's a lot of thinking going on. Why some people, like only 20% of people, even we're not talking about the healthy ones, and even the not having any precondition, also those people, those person are severely ill because of coronavirus. I did a little bit of research on social distancing. Why social distancing is kind of crucial in that case. So if you this value R0 is called basic reproduction number. So R0 is, for example, if the one person, if you think about UK, I think I remember 2 months before there were only one person infected. And if you see after 2 months, we have so many cases now, the situation is totally different. So the spread of this virus is exponential. Why it is exponential? If you think about influenza or other viruses, there was an R0 was 1. That means one person was infected, another one person. But here, what is happening? The one person is infecting another 3% infecting another 9%, 9% infecting another 27%. If you see mathematically, and there was an Oxford research on that as well. There was a paper I'm referring to, and it is spreading exponentially. That's what most of the government are going for the lockdown, and they are delaying the spread of it. Because if he block that on the one R0, no, like not contacting anybody else, that means he or she not going to impact uh, like 3%, and that chain will be broken. So that's the whole idea. So when they're saying flatten the curve, so if you see this graph here, so R0 is greater than 1. That's not a good sign actually, because that means and that was, I think, 2 weeks before. If you think about UK, the situation was like that: R0 greater than 1, number of cases was increasing, number of casualties was increasing. Now I think we are moving towards R0 equals to 1, but still not R0 less than 1. That's what we want to go actually. So we want to de-accelerate the spread of the virus. So that's why social distancing, lockdown is very effective. In that case, it was not that uh, was not thought in case of SARS and MERS, because their spread was not. They were more kind of critical symptoms in terms of those, but they were not spreading as fast. But here, situation is different, and this is kind of overwhelming the healthcare system as well. So there is a concept called like herd community. Is it still herd immunity, herd community? Is it still possible? So there is a lot of research going on in this area as well, but um, there is no conclusive evidence to support that. Sweden has a different approach for dealing with COVID-19. So every country is trying the different approach, but there is no model which says like their approach is fine. Also in that case, so antibiotic doesn't work against coronavirus. We know that, but do we have vaccine yet? Yeah, there is a lot. There is a one uh, Oxford research project. They're trying the vaccine, and what they're doing. They have harmless virus, which is if we do that, inject the harmless virus, then COVID-19 virus doesn't really impact that much. So there is a lot of research going in this area. Then plasma therapy is one which is also happening. So they're taking the plasma from the uh, those who already recovered from the COVID-19 and they have antibodies. So taking those, and there's a different cure which is happening at the moment. But vaccine it's a process. It takes time. So it's like the human trials start happening. It will take time for 6 months to 12 months. So we'll see around end of the year if there any vaccine coming up. So these are the features I talked about, what we can consider when we are building a screening and diagnostic app. But when we are talking about AI, so it's kind of a different definition of that. So there is one interesting thing. I think I read it in one of the newspaper. AI predicts coronavirus could infect 2.5 billion and kill 53 million. Doctors say that's not credible, and here is why. So that because what AI works on, the AI algorithm works on, they works on the data. So at the time, the data modeling was saying that, but now the all the countries, they are going for the lockdown. The data is saying something different. So when we say AI saying that, that means the data, which is kind of we are feeding back to the algorithm, that is the decisive factor in that. So that makes the result which way it's going to go. So AI, artificial intelligence, what we call it, it is kind of indicates algorithm solution to complex problems, which is kind of solved by the difficult to solve by the humans in that case. So AI is kind of generic term. When we say machine learning, it's a narrow AI. So for example, when I'm using machine learning techniques to create an app for screening a diagnostic app, that is kind of, I'm applying some concept of machine learning. Deep learning, we are going a little deeper in where the algorithm learns the structure and rules from the data, and it's kind of more like more complex, sophisticated architecture for the neural network we apply for. There's another term goes for the general intelligence, which is when we think about the machines becomes as smarter as humans. It's kind of, there is a lot of research going into that area as well. Some people saying it will be like 5 to 10 years to achieve general intelligence, but let's see. I mean, this is one part. Uh, then now I'm going to, so this is till here we got an idea about what are the features we are trying to extract. What AI algorithms. In this case study, we applied for the deep learning techniques in there, which is more like more sophisticated, because we are dealing with the data, which is need to we can't be solved by the traditional machine learning techniques. So this is the company startup Vastmind, which co-founded with the two of my friends, and we are using non-invasive diagnostic technology, and it's more like data-driven healthcare. And we are the part of the Microsoft startup program as well, so we are working with them very closely. So this is the core technology I was talking about. So we talk about the features, and what when I talked about the research I did, the respiratory rate or heart rate variability and how it is imported in that area. So we are looking for real-time values for heart rate variability, oxygen saturation levels, respiratory rate, mental stress levels, core body temperature. That is another feature which is really important in that case and very hard to measure in terms of like non-invasive way, not like not using any devices in that sense, which is directly attached to the body. But core body temperature can be determined by the, for example, if you think about it, when we have fever, what happened? So what happened? Like the automated ANS, autonomous nervous system, directed by hypothalamus, they got and some allergy or infection happens. So what it does, it kind of simulate the situation and says to the hypothalamus, okay, there is some cold situation somewhere. So it's raised the temperature of the body. And why is raise the temperature of the body? To kill those viruses and bacteria. That's what happened. That's why we have the temperature. So by increasing the temperature of the body is activating the defense mechanism of the system. That's what it happened. That's why we got fever actually. And this is one thing happened in case of COVID-19. When there is an infection happens, the virus, so it increases the body temperature, and the body temperature goes around more than 100 degrees Celsius. But we are doing a lot of research on that to calculate the core body temperature. There is no direct way of measuring it, but there is a way we can do it from the heart rate variable from HRV. There is a way to see whether it's different classes of the temperature, whether it's a high temperature or it's a low temperature. So there is a way we can give a little bit indication on that. So if you see this, the technology, so we are using the signal processing technique. This is one of the AI technique actually, where what we do, if you see here, the light refracted through the skin here. If you see this arrow, then it will be comes back in some sort of RGB signals. This is red, green, and blue signals. And these three red, green, and blue signals we passes into the algorithm in the signal processing, and that becomes a PPG waveform. And we use remote PPG. So idea is to use this app, and when so there's a plan to have iOS and Android app, and somebody looking at it, and there is a video for around 60 to 90 minutes. So after the 60 to 90 minutes, we took those RGB signals, converted to the PPG waveform, and feedback to the algorithm, and finding those vitals actually. So that's the kind of, you can say, the main component of the algorithm, and that is done from the fast Fourier transform. There is a way to analyze those signals, and so if you can see this picture here, so this is the kind of, we call them ROI, region of interest. So if you see all the little dots here, that's where we transform those, convert into the RGB signals and in the waveform, and after that, and then you can see those signals here as well. So these signals, and that is another interesting stream, the part of the AI, which is kind of very one of the specialist area in kind of in that sense. And we are using some other algorithms as well. We are trying the convolution neural network. We are trying a lot of research going on to get it right. And but it's not easy to get it right, because there's a lot of noise in the signal when you're getting remotely actually. So when we are getting that feed, so the challenge is to reduce that noise, and that's what we are working a lot on that, and having those features reflected on the screen in the app. So this is how we are packaging the solution from the front end point of view. So any device with an embedded camera, so there is the iOS and Android app, they can install it, and they can have the video for 60 to 90 minutes, and they have the vitals presented through the app. So take the input, a video feed of the individual face, and before running computer vision techniques. So there is a different libraries we are trying out here. Mainly the main code is in C++. Detection and so they have the 300 frames actually we took first, and they analyze those frames and then extract the vitals after that. Because if you go for like 100 and lesser than 300 frames, that might not, there's a lot of noise might be in there, and there won't be like enough to extract from those frames. And the target market we are looking for here is of course we are in the virtualized world, and I don't know for how long we have to adapt that to working now, the virtualized. And I think hats off to Elena to organize the virtual hack in like 40 different countries, and managing it is a kind of very challenging job. But I think this virtual way of living is going to be for long. We don't know how long it's going to be. So that's why telemedicine is another area which you're looking for to help out, so that if somebody they don't need to visit to the doctor, there will be a diagnosis through the app, and what's the vitals values are. Then there will be a connection with the telemedicine, and then they on the basis of that real-time health vitals, they can give the remote prescription and the dose modification. So that all can happen in real time, and all can happen without actually visiting the NHS. And that's kind of the future we are anticipating. But let's see. Another thing we are targeting life and health insurers. So this is another target customer, sports and wellness. Of course, this kind of mental stress, or if we can find out the heart rate variability, what's the value of it. There's a certain value for the certain age categories for the HRV, and from that we can determine a lot of indication of the person's health. So that's another thing you're looking for. So these are some reference papers which I put all these together, which I did a lot of research on that. So there is a research paper, and there is a GitHub repository as well, which is And so one of the paper where I did some research on the genome sequences for the viruses, and it was classifying the virus whether uh, it's kind of coronavirus or not, because that's what I think in UK we got around 6,000 um, healthcare small to medium organizations that are working together to create some sort of ecosystem, and I think there's a lot of things happening in that case. And healthcare and cybersecurity, I think there is a lot of um, work has to be done. So if you're thinking seriously into healthcare, or those who are already looking for going to the medics, and I think going through the AI in healthcare or data-driven healthcare is going to be a really good career prospect for them. And of course, that goes in line with the cybersecurity. So I've been doing cybersecurity last 10 years as well. So I'm more like work with the startups, healthcare and cybersecurity to scale them AI, and they're kind of together. And this is what I think from career point of view in the meditech, bit of AI, bit of understanding this ecosystem is going to help a lot. Because if you see the trend of the pandemics, so for example, 2002, 2012, and 2019, and I mean, there is a maybe next one will be in 10, 20 years. So this is a kind of thing we're looking for. Yeah, so that's me. Thank you very much. Yeah.
Fantastic. Sarah, are we
Thank you.
online, and do we have any issues with the sound? I think we seem to be okay. Great. So thank you so much, Raj. That was very informative, and I hope you all found it really useful. I'm only going to take one question, and the rest you can all ask Raj in person in Discord, because he is part of Discord as mentor. So the question I'm going to ask comes from Jordan. How can we use AI to increase testing rates in countries such as the UK, where insufficient tests are being carried out?
So that's this app. What we are building here, that will be launched, I think, first week of next month, and that has. So we need some sort of non-invasive way where through the app we can find out what are the if there are any significant symptoms of the COVID-19, and we need AI to create some sort of those apps where there is a way to find out remotely through not actually going to the drive-through or the healthcare center. So that's the only way to, and that scale as well. For example, if you're launching our app in next couple of weeks, so we are expecting at least 1 million downloads very soon, because that is going to be very useful. So it has to be a two-way process. One is we need to have this 3T framework: test, test, trace, and track. So the testing is definitely useful, and this app. So and we can. There is so many ways we can do it. There are some algorithms, and you can talk to me offline where you can build some sort of testing mechanism. It's hard to do that, to get those things right in the first place, because these algorithms are sophisticated, and to get the things right is challenging actually, because we need to tune the algorithms a lot. But of course, AI can do a lot of help in if we can use in the healthcare. It's a lot to contribute in that. And the next, if you think about next couple of years in healthcare, a lot of opportunities to work in AI and big data. It's a lot of opportunity to work there, because there is no. If you think about SARS and MERS and all these, there is a genome sequences. So there is some sort of unique identifier being stored, but they are not available to any hospital. They are not available in terms of APIs. They are not available in terms of some sort of aggregated data, so that hospitals can make a decision whether this is the coronavirus. For example, in Wuhan, if they have the access to those everything, and they know, yeah, this is the novel virus. This is not what we encountered something before. So they would have stopped it then and there rather than spreading it. So it's testing, tracking. I think there's a lot of work has to be done in that area probably, and we'll be launching that app in Ukraine as well. We'll let you know. Just keep in touch.
So, and are you launching this app? Are you working with NHS or anyone else in partnership with, or?
Right now, we are working with Microsoft. So they are our co-seller actually. So once we develop the app, but we are looking for working with the insurance companies, or NHS will be another potential collaborator in future once we build it. Yes.
So you're talking about potentially billions of people downloading, millions of people downloading this app. What is your strategy to market? So some of our young people are developing some interesting solutions. We haven't quite covered the route to market. I know business mentors are very busy working with teams. What will be your strategy, your route to market, to let everyone know about your product?
So another what we are using different research organizations as well. So recently we contacted Imperial College of London, and there is so the researchers down there, and so there's one channel where we can talk about. We are targeting B2B, B2C. So initially there will be a B2C for the screening and diagnostic app, and there is another approach is we provide SDK to the B2B market. But for the consumers, for the B2C market at the moment, we will be associating. Of course, we are associated with the Microsoft ecosystem, so that will help us a lot, and to derive a promotional strategy in that sense. And there will be other marketing strategies which you are looking for in terms of talking to the NHS is going to be another one, and there is other. We'll be joining hands with Bill and Melinda Gates Foundation as well. That's the one thing we are looking for, because initially our plan is to launch as AI for Good. So we are the partnership with Microsoft, the AI for Good. So the different charity organizations where we can approach.
All right. Okay. Thank you, Raj, for that. Very interesting. And everyone, Raj is one of our mentors in Discord. So if you have any questions, technical or whatnot, please speak to Raj in Discord, because I know you have got lots of questions coming up in YouTube. And on this note, we are going to end our stream. It's 6:36. We are just a few minutes late. But it's perfect. Now you can get back to your teams and work with your mentors. You still have a little bit of time. And over the next couple of days, we will carry on with the same flow. But towards the end of this week, Thursday, Friday, we are going to focus more on the business aspects of product development. So if you have any questions related to that, you should be asking your mentors about all these questions right now or sooner. On Friday, we have a very special guest joining us, giving you an overview of what your pitch deck should look like, and giving you some advice on how you should pitch or how you should not pitch, because that is really important. And you will be in front of the judges who are industry experts, and all these questions will be responded to on Friday. But in the meantime, enjoy your time with your teams, carry on working, and we are going to see you in Discord. Thank you, Raj, for joining us once again.
Thank you, Elena. Thank you very much.
Thank you. So, Sarah, I think we can end the live stream on this note, and we're going to reconvene tomorrow at 5 o'clock. But I can see a lot of questions are coming, and Raj, please do respond to them in Discord. Thank you all.
Thank you.
Good evening.
Thank you.